So here is the plan. We're starting Unit 7 today, which is parameters, returns, and libraries. And when the meeting connects, you'll be able to see it. So let's look at the calendar for a second. Key to mute it. Okay, so the calendar right now, we're starting Unit 7, which we'll be able to do 1 and 2 today. And I'm going to be out actually a couple days next week, which I'll have things for you to accomplish, not just catch up situation. Oh, wait, let me, there we go. Let's not do audio, and we'll go like that. Okay. If you keep your laptop closed, that'd be fantastic. We're up here now. Thanks. The plan is to get through the Unit 7 by middle next week, because next Friday right now is still Create Task Day. I've tried to convey the importance of this in the past, and I will continue to do so. Please make sure you are here. Obviously, if you're in the hospital or something, that's acceptable, but you'll be able to follow along. You join the meeting, okay? It's a joke, but obviously it's important. If you're not here, you're going to have to watch the replay, and it's a lot easier if you're just here, you know, sort of receiving the information and asking questions. All right. We are starting a new unit. We're starting Unit 7, which instead of having that complicated explanation of how to get back to other units, there are just direct links to past units, because when you go to My Dashboard, it should say current unit is Unit 7. Okay, parameters, returns, libraries is our new one. And the old one can be gotten to from the direct link to Unit 6. Also, there's a direct link to Unit 7. And the create task coming up is actually its own unit as far as the code.org curriculum goes, where it's just essentially one lesson where you do your work with a couple other, broken up into lessons, resources. So that's how you're going to get to that. So let's jump right in to Unit 7, parameters, returns, and libraries. We've done, if you were in my class last semester, we did parameters when we did the digital scene project, where parameters are the way you can make functions even more customizable, where you can make one function that does several things based on the details you send it when you call the function. So there's a brief video from code that is, we're going to play it up on the screen here through the other computer. So you might not hear it if you are watching the replay, but this is the one we are going to watch. And let's see here, I'll go like this, and here we go. That's not going to do anything. We'll go like this. There we go.
So far, you've been using functions to make it easier for a program to do the exact same thing lots of different times. But sometimes you want a function to do things a little differently each time. Maybe one time you want a star element to move, and the next time you want the moon to move. Or maybe you want to change the color of everything on the screen to green, but later red or blue. Writing a new function for every element or color you might want to use would take up way too much time. So how can we create a function that does almost the same thing, but with tiny differences? To do that, programmers use parameters. A parameter is an extra piece of information passed to a function to customize it for a specific need. Let's take a look at how they work. Imagine you created two functions, one to move a bike across the screen and another to move a motorcycle across the screen. These two functions are almost exactly alike. They both use getProperty to find the x position of the element, and they both use the counter pattern to add 5 to the x position. The only difference in these two functions is that one uses bike and the other motorcycle. When you have two functions that are almost exactly alike, but with one little difference, that's a great time to use a parameter to combine the two functions into one. To start off, we'll need the function block that includes a parameter. Since we don't know whether we'll be moving the bike or the motorcycle, let's just call the function moveVehicle. To figure out what goes inside, we can look at the two functions that we already have. We'll definitely keep the code that's the same in both of these functions, but the parts that were different will need a parameter. A parameter is a lot like a variable that we can only use inside the function, so we'll want a descriptive name, like vehicle. Also, like a variable, it doesn't need quotes around it. Last, we'll change the default parameter in the parentheses to our parameter name. Now that we have our combined function, it's time to test it out. When we call our function, we use the parameter to tell it whether we want the bike or the motorcycle to move. This time, let's move the bike. Now, every time that the parameter shows up in the code, the program will use bike instead. When we pass in motorcycle, the program will use motorcycle each time the parameter appears. The best thing about using parameters is that we can use this function with any element, even ones we haven't thought of yet. Let's say that we wanted to add a space shuttle to our code. We can add the shuttle image in design mode with the ID shuttle. Now, we can use the same function to make the shuttle move across the screen, even though we hadn't even thought of the shuttle when we first wrote the function. Instead of creating 3 different functions, we've used just one, and it will work with any other elements we add to our screen. Parameters let us use the same code to solve problems that are similar to each other, even if they're not exactly the same. By using parameters, you can save yourself time and make your functions even more powerful.
So go ahead and find your way to the current unit. Alt, Tab10, and one is there we go. And we'll put this up on the back screen. Okay, all right, we're starting. So there aren't any deliverables for lesson 1, but we are going to take a look at lesson 2. And again, here momentarily, we will have another opportunity for, or not opportunity, a situation where there is more to be done than what the instructions at the top of the page tell you to do. In fact, quite a bit more. In order to justify lesson 2 as an assignment, that is what we're going to do. Okay, so it's really more about the next one, but about bubble 2 is going to have a lot of extra stuff. But we'll take a look at bubble 1 as well. And hold on a second. Sorry, I need to get. I can't believe this closes every time. Sorry, folks. I need this. And go ahead and take a look at this. I need about not even 2 minutes, like a minute to do this, to load this up. And why are we not doing anything, folks? Come on, computer. And we're getting close. And okie dokie. Let's go like this. Let's run that. And there we go. All right. So here we have a sort of jerry-rigged kind of basic calculator, which that's not what I wanted to do. We'll let somebody into that. Excellent. And okay. So the basic function calculator is really a sort of spread out just program that receives based on the button which parameter it needs in order to complete the arithmetic. Okay, so we only have 3 event handlers because there are only 3 events, and each time it calls the same function, but sending it a different parameter. Technically, these are arguments when they're sent and parameters when received, but I'll refer to them both as parameters, except when I remind you that they're also called arguments, technically. Okay, so when it's called, whatever is in the parentheses is being sent or passed to the function. And it doesn't matter what you call the actual parameter, because it's just like a variable where it gets assigned to this name, essentially local, like a local variable, and anywhere in the function where you use the name of the parameter, it's as if you're using whatever was sent to it. In this case, the function is set up to check what is sent in, and it has this conditional where it's checking the value of symbol, which is going to be a specific string, either space plus space or space minus space. And the third one, the multiplication, since it has to be one of those 3, the else is the multiplication, even though it's not, there's no condition checking for else. I mean, there's no condition checking for multiplication, but the point is that it's passing that string, which ends up working as the arithmetic, to the conditional, which the result is the this long string, which normally when we talk about concatenating, it's string to string to string. But in this case, because it starts with a number, when we concat strings, we are actually doing the arithmetic. It's doing the arithmetic for us, which is a weird way they've explained it. This little bit right here is checking for even and odd, and I think we've done modulo before, or mod, or modulus. I'm not sure which is the noun and which is the verb. I think modulo is like division and modulus is like divide. I'm not positive. You could just say mod. And that is, we've talked about this completely different arithmetic operation where it's division, except the answer is the remainder. And there's a lot of ways you can use that arithmetic in a clever way to solve different problems. But in this case, one of the most common is checking for even and odd. If you divide something by 2, you either have 0 remainder or 1 remainder. Not counting, we're not doing fractions. We're not solving to the decimal. We're dividing, and then the remainder is either going to be 0 or 1. If it's 0, it means it divides evenly into 2, so it's an even number. And otherwise, it has to be an odd number, assuming we're dealing with integers. And the whole setup of this is its return. Okay, we will talk about this whole thing. The idea of a function with parameters is it's almost always going to be a return function, meaning this entire function, instead of doing a thing, it's calculating a thing and giving the answer back to wherever they called it. Okay, normally when we call functions, we just have them sort of out in space or inside of the event handler. Okay, but that's not how we are using return functions. We are using return functions to sort of, it's called calculate, but take this input and return the result. In this case, the return is a number. Oh no, I guess technically it's a string that somehow it's calculating. But these comments are critical when you have functions that receive parameters, because you need to know what data type you're sending. you are going to be sending more than one parameter on many occasions. And sometimes the first parameter needs to be a list and the second parameter needs to be a string or what have you. The order will matter when we have more than one parameter, and we'll get to that. But the comments are going to be required moving forward, where they include the data type of what's being received, in addition to an explanation of what the function does. We have a comment of what data type and what is expected as the parameter, and then the data type that is going to be returned. And so the basic idea of how this works, of course, it's a basic calculator that will do, standard arithmetic. I guess 4, but 3 function arithmetic. And let's see, what can we add to it? We're going to just add a basic divide button. And then instead of even or odd, we will say whether or not it is a multiple of 3. So first thing, in order to add a divide button, we need to add a button, which if you want things to match exactly, you can just go to any of the ones you like and do duplicate, and it will make it exactly the same. Obviously, we're going to need to change it a little bit in order to have be a division button, and it gives the generic name, but it keeps whatever properties you have. The way they get that in there is with an icon, and I don't think there is one for division, which is lame. We can just do a /, but we need to turn off or get rid of the image, and then in the text we can just put a slash and adjust all the other things. It's probably black, and it's gonna be no, larger than that. And do we have a better font like that? I don't know. That's close enough. And this function is called button2. Let's call it, what do we've got? Multiply button. Let's call it division button, or whatever you think is appropriate. And we need an event handler for this. Okay, so we'll bring in an event handler. The event is for the button called division button, and we click, we want to do the same thing that we've done for everything else, except instead of sending it a multiplication, we'll send it division. And now we have a fourth situation where we can either check for division here and do the division thing here and leave the else for multiplication. But I'm going to just sort of keep it the way it is. But here, now we do need to check for multiplication, and it's the same as the other things. Symbol is what we're assigning it to. If symbol double equals, and then the multiplication thing, because we're keeping this one multiplication, we give it multiplication. Otherwise, the only way it would ever make it to the else is if it's division, and if it's division, we want answer to get number 1 / number 2. And let's do, there we go. And so that works. Let's do no, I don't want to do rounding because then you'll get wrong answers. Especially if ends up a decimal. But we'll just move forward, and checking for a multiple of 3 just means if we divide by 3 and there's no remainder, it's a multiple of 3. That's how division works. And if if answer, which is the result of our basic arithmetic, divided by 3 has no remainder, that means the answer is a multiple of three number, and let's go, let's put some space in there. No, why did it do that? That's weird. Answer is not a multiple of three. Okay, and let's check it. Let's do 9 divided by 3. And answer is a multiple of 3. What about 9 divided by 2? Is not a multiple of 3. Okay, so that's it. Those are the only changes we made, which, if our explanation is about, or the bubble is about parameters, we did address it, but a quick reminder of how conditionals work and a little side trip with modulo was our benefit. Okay, so let's go on to bubble 2, which bubble 2 is actually a 10 out of 10 example of an app for the create task. We will talk about the requirements, but a couple of the requirements are the use of a list to manage complexity, which basically just means you have a list that changes size over time, or as the program runs. Anything with a filtered is going to count for that. Other mandatory sort of tools for your create task are things like functions with parameters, loops, conditionals, that sort of thing. And this has all of them, and it's all things that we've done almost entirely this semester with very small things from last semester. All right, so how does this app work? This app starts with the get column from the dataset words, which words is a very long list, and useful for this type of a category of app that would probably be called productivity. Let's just for fun, let's see how long it is. How long is word list? Let's console. I think it's like the first couple thousand most common words. It is 4,953 words long, which, I mean, we could have gone to the data set and figured out that there are 10 pages of 500. But there's some interesting ways to apply this, basic parts of speech stuff. But here we are only interested in the list of words, like the word list, literally, and the length of the words, which the goal of the app is to have the input from the user of the length of a word and the first letter, which is actually, I don't know, is pretty useful for many different word games. Like I guess Scrabble doesn't really care about word length, but things like yeah, crosswords for sure, and I don't know. There's many games that deal with words and word length. But yeah, I'd say crosswords for sure. But we are going to adapt this to do something else. Let's take a look. First, there's only one function. It is called filter, and it's called right away, and it's called anytime either of these dropdowns change. It calls it again, and it is receiving two variables. Excuse me, it's receiving two parameters. One is the length, the value of the dropdown for number, and the other is the letter from the other dropdown. These are different data types. The first one is a number, and the other one is a string. Now, they have done this to lowercase situation, and that is because we're trying to match a list of uppercase letters to a data set where everything is lowercase. So you need to give it situations that would actually ever come up with a match, like right there. And so every time it's called, it gets passed the value of this dropdown and the value of this dropdown, which it doesn't matter what you call the parameters, so long as they are in the right order. Okay, where we are calling this, the first parameter is the get number, and the second parameter is the get letter. Okay, they have to be in the right order that they are expected. Otherwise, it's just, it's not going to work. Okay, then once we get it, there's another, like, they just sort of hide these really clever solutions that I don't think I would think of without seeing it. But this app and App Lab in general is actually kind of slow when it comes to dealing with the data list. I'm not sure what the situation is, whether they are importing the list every time, but I do know that loops are in general slow, especially when you're doing it 5,000 times. And what they've done is they've created, if you go into design mode, you can see here that there is an extra text box that is, it's probably a text area. I'm not sure. It doesn't really matter if it's a label or text area, but it has a translucent background color, 45% visibility, and it covers up the dropdowns. And there's also waiting image, which is this also. But the key is this text area called unclickable. When the function starts, it shows that element, meaning makes it, it conjures it up. It makes it exist. It runs the app, or excuse me, it runs the function, the loop and everything, and then it hides the same element, which means it's only visible because all this stuff runs in order. It's only visible while the loop is happening. It shows it, it runs the loop, and then it hides it. So when you're actually doing the search, you can't click on anything. Okay, so I mean, I think that's pretty clever. And so the waiting image, which is the what's it called? The hourglass. It also has the same treatment. And then the output is whatever gets, oh wait, so we have our filtered list being wiped at the beginning of the function. It clears out the text output every time, which makes sense. We don't want it to be cumulative. And then we run our loop. We check every word in the word list. And if the length of the word we're checking, remember the word we're checking is the name of the list at index I. We're checking word list index I. And if its length is the same as this, whatever number gets passed from that dropdown, and the substring of that same word list index I, the thing we're checking, remember substring takes a string and returns, a part of it, a sub part of it. And based on the places that you put the, place the dividers, and if that matches what was passed in with letter, it's a match from our main list, and it gets added to the filtered list. Okay, and when it's done, we have the same thing we've done before, where we end up with a list of words, except instead of choosing one at random, we have the output is the .join situation where we have a full list, and .join turns it into a single string with whatever thing in between it. We've done this before with new line command, and that will put everything on in a column, which may or may not be the right output for this because it clearly extends, which makes me think that this is a different element. I think this might be a label, because like labels and text areas, I think have the same set of properties. So you could technically make them look identically from a background color and text color and shape and everything. But one of them, I think label doesn't do like scroll, where text area does, we can test this in a second. This thing is called output. Let's call this output 2, and we'll call this output 1. This is critical research. And well, the text color is white. So wait, did I call this out? Oh no, it was called output nothing. And we go like this, and yeah. Okay, so text areas will result with a scroll bar, labels don't. It's not critical. If you have a situation where the output is a scroll, maybe you want to change it. I don't know. That's never something that I'd grade you on, so long as things work. So the change we're going to make is we are going to have it so that instead of giving it a length of word and a starting word, we are going to make it so that the user can type in some letters, and we will return all the words that start with those letters, which, if you're thinking ahead, offers the challenge of searching by different lengths each time. Because before we were only interested in the first letter of the words from the word list, and if it matched the dropdown. Here we need to match the first letter of the word we're checking to the first letter the user put in, the second to the second, and the third to the third, and so on. And that's what we're going to do. So first thing we need to do is get a text input. Go ahead and do that. Let's call it, I don't know, I always like starting things with user if it's something they do. I don't know what you put here. And so one common thing that I'd say happens to a lot of people exactly once is the text input has different properties. People will bring out a text input expecting it to be a label, change the text color, and the text color doesn't change because the text color is the color the user types in, not the color of the placeholder text. Okay, so text inputs have that different placeholder property. Okay, so we have a place to type. That's all we need. I guess keep the unclickable thing, but you can see how the dropdown was brought in after that. That means it's on top of it, which we can fix that by selecting the unclickable, coming down here to depth and moving it all the way to the front, which will make it on top of in terms of layers. And again, this is not a sticking point for me, but it's still should be fine. In fact, actually, for now, we're going to move this out of the way because it may cause issues as we are debugging it. And both of these, this function, well, both of these event handlers we can dump, and because we aren't using those events anymore. And so we need a new event handler. And I'm actually going to get rid of this for now so we can do a quick debugging. And the element that we're dealing with is user text. And we want it to be one of the things that happens every time the user types. So we'll figure out, just to recount, we'll console log the text from that, from user text input, when the correct, okay, so it's not, okay, you can see when it's actually being run. I believe it's either I think it's input, where you can see the output down here, it changes, which means it's running every time I click, it's getting that data. And this is one of the few times we are not going to have a clear out the text area, because think about if you're searching for something with, whatever letters, and you want to go back to search something with one fewer letters, you don't want to have to type in the same every time. I think it works better that way. So what do we want to happen? Well, we definitely want to call the function, which you can add and remove parameters with the little arrows here. And the thing we want to send is that text. Obviously, we want to call it filter. And so every time the user inputs, we want to get the text, and that's what we're going to send as our parameter. And we only need one parameter to receive, and let's call it, I don't know, user text, something like that. It doesn't have to match. That's something that I think people struggle with. Whatever gets sent in this gap here gets assigned to this word. It doesn't matter what you name either of them. It knows whatever's the first thing in the parentheses is that thing. Okay, so we like the same basic format of showing the different things and hiding them at the end. We like our filtered output, and we just need a loop. So our loop is going to do the same thing as going through the entire list, but we aren't checking either of these things. I'm going to save the append item thing because I know that's what we want. The question is, what is our condition? All right. So we have a loop. We have this loop is going to go to each of the words in the word list. And what is the algorithm? What is the general, without coding, we need to check if we need to get the first however many letters from the word we're checking and compare it to the user's input. But we are only interested in the first however many letters the user typed in, which will be user text.length. Okay, user text is what the user is typing in, and user text.length is how many characters are in it. So we need a way to grab user text.length number of characters from whatever word we're checking. So let's get a variable and let's call it word list, no, word, what's a good one? Letters checked, letters to check. I don't know. I don't want to use the numeral 2, something. I mean, it's not super important. And we'll give it a, I don't know, word letters. I'm just not satisfied with that, but it works. Okay, so we're going to create an empty variable, and we need to go and get the first however many letters of word list index I. So we can then assign, well, we can actually do this in the same situation. We don't need to give it an empty string because we are going to do a substring, which is will return a string. Okay, the string we're checking, the string we want is the string we're starting with is the word we're checking, which is word list index I. Okay, we'll go to each element in the word list at whatever index we're checking. And the letters that we want are, the range we want is, well, we know between 0 and 1, which is what was there before. Between 0 and 1, we'll return the first letter. Okay, and we'll return a single letter. We showed this before where the two parameters for substring are where the first one is where you want the cut to be in front of, and the second one is where you want the cut to end, but in front of. If you are confused by that, the unit or lesson 11, I think, from the last unit had a, let's go. Actually take this. Somebody stole all my cardboard passes for some reason. I don't know who doesn't return a cardboard pass except the name. Okay, so how many letters do we want? Well, we want the cut to start at the beginning of whatever word we're checking, and we want it to end at user text.length, which .length is the number. So this parameter, this second parameter of the substring needs to be a number, and user text.length is that number. So we have gone and got, every time we get to a new word, we get the first however many letters from the word we're checking. Now we need to do the actual checking. Okay, so what are we actually checking? We are checking if user text double equals letters checked, or whatever we called this. Letters checked. Okay, and if they match, it's a match. Great, we append it to the list. Same way we would have with the last one if we got a match from the two drop downs. Clean this up a second. All right, so we go and get whatever's in the first few letters of the word we're checking, which is always going to be the name of the list, index I, as we go to each one. And then we check it if it matches, if that many letters match whatever the user typed in, it'll be a direct match. We're going to add it to the filtered. We still have our check if it ends up being empty. If after the search it's empty, what actually goes in the list, even though we'd normally set this as like a set text, like a direct set text, but since we already have the set text here, they just sort of put it in our filtered word list. Even though this isn't a filtered word, it would just fill the thing. And let's test it. Let's see if it works. Okay, hit run and type T and ID parameter ID. Okay, so filtered word list. Where do we miss? Filtered word list. Let's see here. Line 16 ID output. Oh, because I changed it a second ago, of course, for fun. And we run it and we try something, and there we go. We get an output. Oh, I guess leave this as comma space so that, because of that thing we explained a second ago. And there we go. Our list will always be all of the words that match the first two. Now, there's a couple of refinements, like when you backspace out of this. Okay, so it searches that one, good, because it's a change. And we search again, and it gives us all the words. I don't think that that makes the most sense. I had other arrangements like checking if it's empty, although I'm actually kind of okay with this. I don't think the unclickable cover up makes a huge difference. We'll hit run and why? Oh, because I don't have a. All right. So the can we? This is, let me. We'll do debugging here in a second. Let's get to a good finish point. So the unclickable situations happen at when the function is called. So we do show and hide, but unless there is a function call, like originally the app had the sort of setup function called. The problem is wait, is this going to work? I think it is actually going to work. Yeah, no, okay, so that's fine. It's just calling it with an empty thing, because at the beginning it's getting the text from an empty text area. So yeah, we need to call it out there in space so that it gets rid of the loading situations, and then it works, I think. Yeah. So there is that. Now, there are, I don't, there are a few words that are uppercase, and we could put a condition in there. Oh, here's an issue. What if the user types in capitals? We do not know. Well, there we go. There is capital. Letters checked. How do we check first capital? No, we aren't going to do that. Go through and check capital and lower for each one. But I do think we should throw a to lowercase at the end here. So we want, where are we getting the user text? We're getting it here, I think inside, let's try this, to lower case, not in caps. And you need the open close parentheses to make this that function. So you'll be ending with a couple of closed parentheses, and I think this should still work. So let's try capital, and we get a lowercase. All right. So that is it for that one. And I think the check for understanding puts us there. Yeah, so go ahead and do the check for understanding. Basic reflection. What are the benefits of writing functions that use parameters and returns? Try to list at least 2. So you can do that. Is this the same thing? It is. And I'm trying to think if we need all of the time. So I do know that we are going to be doing lesson 4 before lesson 3. And the reason we're going to do lesson 4 before lesson 3 is lesson 3 is just ridiculous. It is one of the apps that has like 7 of the same bubbles or 7 of the same workspace, where there are 2 practice apps with examples on bubble 1, and then bubble 2 for each of them, and bubble 3 for each of them, which we've done this type before. The problem is that they are super complex that I have struggled to even just get through doing, let alone explaining. But I do think we'll do it eventually. The lesson 4 is a much simpler situation, which I think we will save. Yeah, we lesson 3. Do we need to do? No, I do think we need to go ahead and do that. I'm sorry. Oh, I'm not sorry. We need to do it all. All right. So I'm going to end this meeting here, and then so we can put lesson, we're going to go ahead and do lesson 4 together right now directly, but let's end this so it can record or process.